safety. This is mainly kind of going to be a discussion based kind of thing. We don't have any code to go through, but it is still pretty technical. So please talk when I prompt you to. Which way does this go again? This way. Huh? There we go. Okay. So to give a quick rundown of just like what we're going to be talking about today, I'm going to start off with just a conversation about like what risk is as like a concept. Kind of going to go over the theory and some subdisciplines and in AI safety, give you guys kind of a high level overview of the field. Then we're going to kind of jump into some of the more technical aspects of this presentation, talking about attacks on neural networks, kind of looking at cybersecurity and AI safety, and then going to pivot and talk about safety and explainability engineering and how we can kind of make these systems safer, and then going to end off on talking about governing in a world of continuous change and how we can kind of build systems to govern AI. So yeah, that's kind of the rundown here. Start off, what is risk? Kind of to give you a mathematical way of looking at what risk is. This is kind of just a little decomposition here. Say risk is the sum of the probability of a given hazardous event taken times the impact of said hazardous event. A hazardous event could be like a ton of different things. Like here, the hazardous event I might be talking about is, environmental security or climate change. And the risk factor with no Montreal Protocol, you can see the trend is going all the way up exponentially there. And that when we pass the Montreal Protocol and when we remove that risk and the potential impact of like CFCs in this example, it's pollutant on the environment, that we can change the risk calculus of different phenomena. This is also kind of true when we look at like pandemic prevention. The vulnerability of someone is one part of the equation, but, we also have to look at like, the overall environment, how exposed they are to a given hazard and how that hazard is actually spreading. And all these, different aspects, compound on each other. And, if you have a lot of all three, you're going to have a really high amount of risk. So it's kind of a non-linear trend here. That's what I want to start off with here. To pivot, kind of going to give you guys a rundown now of what the field is looking like. And I kind of want to start getting your guys' opinions on what it means to make safe AI systems. So bear with me now. This is kind of a historical rundown of the field and kind of research going on. But the first thing I kind of want to position here is John Searle's Chinese room argument. We kind of talked about this last quarter in the ethics lecture, but the Chinese room argument is basically saying we don't have a great idea about how strong or weak a given AI system is because they're in black boxes here. So he kind of used this dictionary sorting kind of algorithm, the Chinese room algorithm, to just show that a machine, we have no idea what's going on, and all it could be doing is looking at a dictionary and just picking out the value and spitting it out and not really doing anything that's actually intelligently complex. On a pivot there, thinking about risk. This is a book, Engineering a Safer World, kind of looking about how we can kind of develop systems to be more adaptable to like extreme risk and existential risks, things like nuclear war, worldwide pandemics, these sorts of things. And also, of course, AI. And a kind of another kind of piece of research in the field that I'll also position here is kind of the definition of artificial and general intelligence. So I mentioned strong AI before. I would think of these kind of two terms as synonyms here for my talk. I am using this, and you guys don't really need to read all of this. I just wanted to put it down because a political scientist actually came up with the first one to use the word artificial or general intelligence. So I kind of wanted to, harp on the discipline there, but basically just saying that AI systems, to be strong, it needs to have a wide kind of range of applicability, that it can't just be able to do one narrow task. And kind of from a safety perspective, after these, books are released, and we are starting to think more about existential risk in AI. We have, over the last decade, and I assume why a lot of you guys are in this class, this explosion and machine learning and deep learning in particular, kind of reinvigorating this field of research and actually giving us some empirical stuff to look at in the field as well. And then just kind of another book, Superintelligence, that's a little bit more recent, kind of talking about, a bit potential of a super intelligent AI and the risks that might pose. Sorry, bad slide organization here. So to kind of pivot away from the history and talk about, kind of these little sub-disciplines in AI safety, I kind of want to just kind of position kind of these different paradigms in the domain. So the first one, and you may or may not have heard of some of these, is robustness. So developing an AI system to withstand those hazards we were talking about earlier, making sure it's adaptable to stochastic change, these sorts of things, monitoring systems, so identifying set hazards and being able to find them out. Alignment, this is kind of a really big piece of the field, especially now with the emergence of these large language models and kind of the public discourse about these systems kind of becoming bigger, and that, I'll get into that more. And then also systematic safety, which is going to be kind of the biggest point of this lecture. So I'll kind of jump in here, but to give you a little bit more of a rundown on what alignment is, I'm going to kind of just hit you guys with this kind of technical definition here, where alignment research aims to build models and build models that represent and safely optimize hard to specify human values. That's kind of a very, technical way at looking at alignment. But I just want to kind of throw this back at you guys. What do you think it means for something to be aligned? This is super high level. We could talk about, building a bridge or, my values, but, how do you determine if two things are aligned with each other, or how would you go about determining that?
Black segment between 2 points.
Mm-hmm.
Is it line, right?
Yeah, alignment. So I mean alignment could be as simple as like in physical space, two things being connected like that. Like those two things that are connected by the line would probably be aligned in some way. Yeah. Take a stab. Mm-hmm. Mm-hmm. So kind of thinking about it a little bit more from kind of that ethical and normative perspective there. And, how we can actually, it's not only physical things that we can align, but also kind of things in our mind that we can align as well. Go ahead.
The two parties identify the same.
Mm-hmm. Yep. Good answers. So kind of two specific ways at looking at alignment here in the field is value learning. So what you guys kind of talked about a bit, building representation for these kind of normative ethics that we have, these intrinsic goods, the morals that we might attribute to our systems. These things are relative in different cultures and societies, but people are trying to come up with different ways to position values. And then there's also proxy gaming and alignment, looking at the way that AI systems can actually become unaligned from the task we specifically, we are trying to get them to do in the first place through over optimization and reward hacking. And on the other edge of this, and the part of AI safety that I'm really interested in is systematic safety. So systematic safety research aims to reduce like the broader kind of context and risks to how these systems are handled. So not maybe looking at necessarily like the models themselves, but the way that these systems interact with other things around them, internet network, for example, or even people. So, one example here, we have AI cybersecurity and, have offensive and defensive uses of that. And also, AI for improved epistemics for decision-making, using AI to, help policymakers make better decisions is also kind of another area of research in systematic safety. And to pivot here, I want to talk about some potential long-term speculative risks that AI systems could play. And this is a place where I really want to open this up and just ask you guys to really throw anything you have out in any of these and just give me some hypotheticals. It could be, relating to a movie or, even just something you come up in your head. But I really want to hear what you guys, how you guys think a system could, develop one of these tendencies. But, the first one here I want to talk about, and I think it will be an easy open, is weaponization. So, does anyone in here, have any, I guess, examples of systems being weaponized or any kind of, I don't know, hypotheticals around that?
I mean, the quintessential example would be Skynet.
Mm-hmm. Mm-hmm. And yeah, and Skynet, and even, today we have, AI systems are being integrated into like every level of the warfighting capability. UAVs were the big advancement in the early 2000s, and now we don't even need remote controllers for those things anymore. So that's one of them. And also, I think, you talked about Skynet there. Enfeeblement is kind of another long-term speculative hazard, something that's kind of more sci-fi. But, I think of WALL-E when I think of enfeeblement. I don't know. Do you guys have any, potential examples of enfeeblement? Mm-hmm. Yeah. I think that it definitely, we can already kind of see, I don't know about y'all, but I can see a slide a little bit already. It's easy to rely on ChatGPT for just information. So that's a good one. Then that also is kind of harps on this point of eroded epistemics, like, what happens when we aren't the ones, making these decisions, or we don't have the driving power behind decision making anymore, and these systems end up becoming the ones that do. You guys want to kind of throw out some examples?
What do you mean by eroded epistemics?
Eroded epistemics, I think that, and mind me here, because these are a lot of this content is taken from a course, but eroded epistemics is basically when the decision-making capacity of, like, I don't know, a given agent is reduced by its reliance on an AI system. So it's pretty similar to enfeeblement, but you're not necessarily disabled by it, but your decision-making and your ability to reason is, if that maybe makes sense.
The books that there's slides people like they given the political power to AI to make the laws because they thought that something make fair. That's the system. In the book, Homo populace, it's more random.
Mm-hmm.
For an evil man, I don't know, maybe it's probably because kind of
Mm-hmm.
I think in the future, like if AI and we summon alignment, like they just like happy, we'll probably just like I'll be in a VR simulation or like I'll be in drugs.
Mm-hmm. That's a based answer. Anyways, I'm just gonna skip over. I already mentioned proxy gaming. Value lock-in is kind of similar on that front. This is just like looking at how systems, what we were talking about, giving systems values before, but what happens if those values become fixed over time? Sometimes, we need things to change. And in particular in like the training and the testing stage of model evaluation, we really need to make sure that the values that we're trying to, give specific model are locked in the right sort of way. It's really difficult though. And then kind of emergent goals. This is one thing I wanted to also ask you. What is a way, maybe you guys could see a system that we're currently integrating into things? I don't know. This is a bit of a hypothetical. Maybe, they don't have the capacity for this, but do you guys see any ways, new systems that are being used a lot could maybe, develop emergent goals and what that might look like for us if a system developed an emergent goal and kind of tried to do something that it wasn't supposed to?
Right now, emergent goals, because that would mean like at least the way I see it, that would mean the AI would have to be sort of changing its own loss function as it's running. If you haven't tried to do or done, as far as I know yet, as far as I know. And like at least right now, I don't like see how that would happen without that happening. That makes sense.
Yeah, I know there is, and this is kind of, I think, a bit of what proxy gaming is. I don't know a lot about this, and I'm not very technical, so I can't really explain it to you, but the concept of a MESA optimizer was something I came around a lot, where these systems, even though, they're not maybe intelligently gaining like new emergent goals, that they inadvertently become like in the optimization process, the optimizer becomes an optimizer in itself. And it can create really bad outcomes, but maybe look at that more if you're interested.
Like, I guess like you'll see those like AIs that are trained in like the virtual system, like where they're glitched through when clearly that's not what they're doing. They're kind of they're supposed to like learn the rules of the game within. So they could get in the learning goal that by finding a quicker way to do something, which we don't, and by breaking rules, we don't think which like smart program. But also like is emerging goal also like the idea where like we make an AI to say do the best for humanity. It's like humanity sucks and it's all.
I mean, yeah, that's that. I think you could also say proxy gaming too in itself. If I tell a system optimized to create the best outcome for humanity, and it, I don't know, decided that the best outcome was just, to cull, like you were talking about before. I don't know, whatever. I think, you're on there on that path there.
response to gaming, the first thing that came to mind when you talked about that was Asimov's laws of robotics. And I feel like an implementation of some kind of that once AI starts, if AI like starts trending towards becoming more generalized, would be the smart thing to do, because I feel like it's just a hypothetical that's been talked about a lot in the past before it even was possible, but to like conceive of it being like actually like something that would be important, or rather like happening, like in life or lifetimes. Anyways, I feel like this is the kind of, we're seeing kind of possibility for an implementation of those that would be important.
For dialogue game, I keep seeing the thing on like computer bomb where they're like, how do you program an AI to like want to do a goal, but also like allow itself to be turned off? Because being turned off is the first to its goal, and it's trying to turn on the next so that it can be like make its best anything possible. And even if you have like an off button, they might like kind of just take that and do that.
Mhm. Yeah. I think that's a pretty good example. And obviously I think right now I don't want to be an alarmist, because like ChatGPT is not AGI. It's not posing these sorts of threats necessarily, but these models are getting progressing rapidly. And these are things worth considering. I'll just kind of go over deception, power seeking behavior. I think so pretty straightforward. And, these are kind of cross-sectional. I wouldn't just break them all up into their own little box, but thank you guys for engaging there. So now kind of to pivot and talk about a little bit more of like, how these issues look in reality. I'm going to talk about some attacks on neural networks and, maybe ways we could make these systems safer from said attacks. So I know a lot of you guys in here have been with us for a while, and you kind of like, know the steps of this. And I don't need to be the one telling you, what's necessarily going on here. Because you guys know better than me. But essentially I just wanted to say, the kind of underlying terminology here, I'm going to say Trojan and I'm going to say data poisoning. These things can happen at the same time, but a Trojan happens inside of the actual like kind of model architecture. That's an attack that relies on some kind of knowledge of the proprietary model, whereas data poisoning relies on like actually messing with the inputs of a model. And anyways, yeah, so those are the definitions here. Kind of to talk about Trojans, since they're actually usually rely on the model architecture, it can be really challenging to detect these. It's caught in a neural network, which is a complex high-dimensional object. If I asked you guys which layer of weights, was Trojaned here, do you guys think you could, give me a reasonable answer? No, I mean, I have no idea. So that's the one that's Trojans. If we look here at a little bit more of an intuitive example of something that's data poisoning, we can see that right now this is just a simple number classifier, but by messing with these kind of little pixels at the bottom of a couple of our numbers, that we're able to get it to mislabel these numbers and output an 8 when it should be a 7, by basically picking up on this kind of hidden trigger in the rate. This attack is, relying on one kind of a knowledge that this symbol here will cause the label 8 to occur in this architecture. So it's a Trojan, but since we're changing the input data, that's also a data poisoning attack. Data poisoning could also be, for example, if I wanted to like muddy the information LLMs have on me online, I could upload a ton of crap because most of them are trained on WebCorpa, and it would probably pick up on that poison data that I uploaded online, without you knowing about the architecture itself.
Would the CNN be able to avoid that misclassification?
I mean, I don't know exactly about if CNN itself could avoid it. And since this is reliant on kind of the Trojan trigger, I think another CNN could avoid it, or maybe you could integrate kind of a model that wasn't trained like this to avoid it. But this attack relies on a pre-existing knowledge of the CNN and like its architecture and the weights in the CNN. So this attack would, I think, be successful in this case. I don't know. I don't know if that's helpful. Yeah.
So this type of attack does work. Convolutional neural networks pick up on patterns. Like that's basically what a convolution is. It's just a sliding window over the image that picks up on patterns adjusted by weights. You can add in more channels and it'll pick up on more patterns, but if you have something like that, it'll probably pick up on it, especially if it's very, very regular between all things. Like if we're comparing something like, I don't know, the 2 in the second row and the 2 in the bottom row, they're very similar, but there's a very clear feature that the 2 in the middle row doesn't have from the one in the bottom. And that's that pattern that all the other ones. So that's something that is a unique signifier for that, and it's very, very specific. So a convolutional neural network would probably very easily be able to solve for this. Yeah.
So is the Trojan data set like, is it trained specifically on it? Like, is a Trojan network trained on the Trojan data set and passed off with the Google data set? Is that what you're saying? Because like, are like the 3 dots in the corner, is someone passing in the data set and labeling the 3 dots in the corner as 8, and then having the data having your own network, oh, it's 3 dots in the corner and it's 8, and then passing that up to someone saying, hey, this number came correct. And like, and the person who feeds in numbers about the 3 dots, like, oh, this works, like the numbers, and then the person was like, okay, and then they give them like 3 dot examples that they were testing on.
So both can be the case. One, your data is really crappy and you have a lot of artifacting in it, like this, where things are mislabeled, and you're going to get a model that is going to give you crap in response. It's going to mislabel things. That's one possibility. Another possibility is, like Dylan mentioned, if you have if you're able to assess how the model is able to evaluate things, you can't trick it. Like, for example, there's like paint that you can put on stop signs that'll prevent the neural network from being able to recognize it, because there's some sort of subpixel information in there that when you block it out, it's not going to be able to recognize. There's patterns that we are able to see just by logical inference that a computer isn't able to. So if you're able to figure out what it is not able to evaluate and feed it some sort of poison like this to get the same result every single time, it does the same thing. So either your data sucks when you're training it, or you're able to figure out why or how it's doing something and feed it garbage after. Same result, different.
Shrish. So kind of to throw it back at you guys now that we kind of talked about these different attacks, do you guys have any thoughts on maybe how you would engineer a defense against these attacks? Like what, I mean, this is a pretty kind of complex question, but just take any stabs you guys might have, any hunches. I'm not an engineer, so I want an engineering perspective from y'all. Mm-hmm. Say that again. No, I'm a politics student. And that was just a what's it called? That was kind of a joke, but yeah. You want to say something now?
Accepted that basically because neural networks are so vulnerable that these corporations are all going to like start developing in-house neural networks that only workers have access to, and then those neural networks will start evolving independently of each other, which will be very scary. They don't really know it's how they're evolving.
Mm-hmm.
But basically controlling who can touch the code.
Yeah.
Suppose we know of the existence of someone who could generate, someone with, uh, maybe good moral quality. I don't know the exact right word to use here.
Mhm.
That could create a neural network to check if the weights are poison, for example.
Yeah.
That seems like, this is just a stab in the dark.
Yeah. I mean, I actually deleted the slide talking about that, but you're onto something. There is a meta network kind of approach where you wrap your neural network in like a classifier and also look at like network traffic and other potential signifiers of, someone trying to attack your network. So you guys are all kind of at a good place there. And I wanted to say too, one of the kind of issues with data poisoning, especially, these systems, especially the way that they're trained, and Jonathan was talking about it before, they can pick up on these triggers with a really, really low amount of actual poison data, out of, this trigger is firing with about 30 out of 60,000 of the examples being poisoned. So is that there? And sometimes we can't tell, like those other examples were intuitive, but this is clean and poison data, kind of talking about the stop sign example before, but it looks identical. So this is a really tough challenge.
You can see the tiny white squares on them. There's some pixels, like alternate pixels of the made slightly lighter. You can see it's visibly poisoned.
And
Like, what happens?
this is kind of just like a hypothetical example. I mean, I don't know, maybe like we could say that this way will, like this poisoned image here will make it think it's, I don't know, like is like I don't know, like a highway sign or a yield sign instead of like a stop sign, for example. So now like all the cars that are going, or all the Teslas going through this infrastructure blow through the stop sign.
Is poison related to that?
It's the same idea. Basically, it's just a different application. One is malicious, one is specifically for artists. So what he's talking about is Blaze, which is a tool that the University of Chicago put out a few months ago, where if artists want to put their art up online, basically what you can do is apply a style mask on top of it, which just basically superimposes a noise pattern on top that you can't use to generate a model to basically steal that person's style. I linked the paper, I think, in the Discord. You guys want to check that out in there in case you haven't seen it, but it's pretty good. If you do post art, or know something does, it's really useful.
Can't generative models use denoising then?
So it's yes, but no, because you're trying to find someone's specific style by using these types of things, right? So by applying a pattern of noise, if you have like a painting of a landscape and you apply some sort of cubism pattern on top of it, you're going to get something really crappy out. And that's the idea. You're not going to be able to steal someone's specific style, and they can upload something with minimal amounts of noise, and it's very, very hard to extract just by the architecture of these models.
And kind of on the direct point of that, one of the solutions I want to talk about here is, called a neural cleanse, and it's basically using optimization to interface with these compact systems and, sift through that noise, essentially. So the idea is, if we know the general form of an attack, that we could potentially reverse engineer the Trojan by searching for a potential trigger in the data set. So this process, and I, cannot explain to you guys necessarily the dynamics of it, but basically X here in every trigger, we go through every potential trigger in our network and essentially evaluate if the labels would exist because of like random noise or not. And that allows us to reverse engineer the trigger. I don't know if I explain that necessarily in the best way possible, but there's a lot more kind of research about this stuff if you guys are interested in that. Kind of to go a little bit further, we don't always necessarily get our original trigger back with neural cleansing, but the characteristics of the reverse triggers tend to be very similar to this. So even though these look very different to us, the network that these triggers were, analyzed on your using Neural Cleanse, basically sees these two things as pretty similar. And that's one of the things, you were talking about before. We didn't necessarily see how those images were different intuitively to us. But the way, these models process this information, you can create random noise in kind of very subtle ways. And kind of looking at here, some researchers basically went and then used these models to evaluate the triggers of different benchmark models. And we're able to basically extract that the models with like the most amount of infected triggers could be kind of culled the most. And we can cull triggers by basically looking at the amount by which they occur in the data set. If a data set is poisoned, it's very likely that that poisoned data is a very small amount of N in our sample. So by clipping like the triggers that have low amounts of samples or lower amounts of samples, we can kind of get a bit of a solution there, but that's not necessarily the best thing either. Okay, so kind of moving on now to talk a little bit more about safety engineering and how at a high level we can create safer systems. I kind of want to go through just some different models that like looking at security and risk and kind of, to give you guys a framework for thinking about these sorts of problems. On the first one I'm going to talk about here is the Swiss cheese model. And it's basically based on like defense in depth. So we have multiple layers of safety or security to minimize the potential impact of a given hazard. Here, it's COVID, and we have all these different policy barriers, social distancing, wearing a mask, doing these things, inhibits the impact. And we can kind of, use a similar framework for analyzing security risks and safety vulnerabilities and ML systems. They don't actually have to be the different layers here don't have to be layered like this, but you do kind of want all of these elements in an evaluation, a safety evaluation, for it to be kind of robust for these systems. And then kind of another way of looking at the impact of potential disasters and events and how we can look at them is the bow tie model. Basically here on the left side, we have preventative barriers, kind of things that we put up to make sure that the systems don't initially have don't perform a given hazardous event. These sorts of things like having the value clarification or gradually scaling our models, allows us to kind of constrain some of these risks on kind of the preventative end here. And then when the actual event then occurs, we have some more kind of protective barriers to then, look at, what actually happens, screening for anomalies, monitoring the model and looking at, those potential recovery measures. This model looks really symmetrical and it's nice to the eyes, but I will say that we need to like really consider security, preventive security before protective security. From a research perspective, we want to, make sure we're figuring out new things, but from like an actual system security point of view, it's really bad for an adverse event to even, occur and impact you. So if you can minimize that impact on the front end, that is, very desirable. And kind of moving away from different ways at looking at safety, I kind of want to talk about, governing in a world of continuous change and how we can integrate these models into the way, we make decisions to, do things better. But also I kind of want to highlight some policies and things that are developing now in relation to AI safety. So the first thing is these are just kind of different frameworks that have developed over the last year or so in relation to like AI risk management and kind of building a material or like ethical framework, you know, in government for, you know, I guess, yeah, governing these models. This is pretty simplistic here, but like the NIST framework is basically, you know, saying, you know, you need to measure, you need to map, you need to manage these things. We can't just deploy models anymore and, you know, see how they interact in the real world or what they're doing. You know, you need a really robust evaluation process at every step of the, you know, process. And then these OECD principles, which are a little bit more focused on, you know, the impacts of AI on society. But also, like, you know, there's organizations are really thinking about the potential impact that these technologies will have down the line on, you know, the labor market and things like that. So, yeah. Anyways, this is something that I find personally really fascinating as a political scientist. That is forecasting and governance and how we can use AI systems to predict what might happen in the future. You know, during moments of crisis, we humans are liable to make bad errors. You know, there's two real examples here, but in general, if we could disaggregate decision making a little bit more, you know, at least high level decision making, I think that would be good for our society. We're too reliant on groups of people and individuals right now. So there's a big kind of benefit here. You know, we can improve that decision making, like I said, reduce existential risks from other AI, and really make sure that like these technologies are being, you know, integrated in the, I guess, in aligned fashion. And kind of want to also highlight just some issues with forecasting. These systems are nonlinear. I mean, that's nice for neural networks, but one of the things is that like the probability and the precision of any of these predictions actually occurring dramatically decreases over time, and that they're really sensitive to their initial condition. So here's one kind of forecasting model that was developed, I think, last year. This is, I don't necessarily know the architecture. It's a forecasting LLM. They basically train this AutoCast model on about 1,000 different questions like this. This one is about, you know, if North Korea will launch an ICB, you know, missile more than 10,000 miles an hour. And, you know, you can see over time, the kind of model and then the crowd predictions. The model is pretty steadily, especially over time, lagging behind the immune predictors, but it's seeming to kind of pick up on this trend. I will say that, so the crowd source is kind of seems ambiguous here, but the crowd are experts, academics, people who know about these issues. So we can understand the crowd as kind of like a measure of like, you know, human accuracy predicting these issues. And there's kind of a lot of things here, and the performance is still pretty laggard, but I think there's a lot of potential if you guys are at all interested in this sort of stuff and, you know, creating more robust forecasting models. I will say also from a kind of position of forecasting, I think we also really want to kind of look at how new systems might, you know, develop new emergent trends. This is kind of just a picture to visualize, you know, what kind of like how systems actually like learn how to do things, like how GPT-3 after it hit, you know, the 10 parameter mark, was able to do 3D addition. So forecasting could also, you know, be used in a way to kind of predict maybe when a model might gain a new emergent ability. So this is kind of, I'm going to open this back up to you guys, and we're just going to kind of have a discussion now on the back end, but I want to kind of read these out to y'all. And I just want, you know, people to take some stabs at maybe who they think these individuals could be saying these quotes. We have a couple different examples here, with the first one being Worrying about AI evil superintelligence today is like worrying about overpopulation on the planet Mars. We haven't even landed on the planet yet. Asking AI labs to slow down, especially in this frankly competitive business environment where labs and countries are trying to build advanced technologies and create a lot of value, does not seem practical to me. The only thing worse than that would be if the government steps in. So I don't know if you guys, this is pretty broad, but if you guys have any flyers on, any individuals, you guys think might have said something like this. It's the same person for each one. And they're not a politician. This is like I guess you could say like Elon Musk's AI safety alter ego. I would almost classify him as now. But yeah, I'll just go through Andrew.
Oh,
Yeah, so this is a quote from his recent, he and Charles Lichun, I can't remember their names all the time. Anyways, yeah, so they had like a talk about this 6-month AI pause that Elon Musk proposed, and he had those thoughts. So he's kind of this AI optimist here. Here's another kind of shorter one. Whoever becomes the leader in AI will become the ruler of the world. Well, what evil figures, I don't know. Who do you guys think might have an opinion like this? And why we might be scared of developing these systems because they have opinions like this? No, we got to think eviler. Like this. Okay. Well, I don't know. Maybe he just comes to my mind first because I'm a political science. But we have Vladimir Putin, big bad man on the world stage. Obviously, Russia is pretty technologically inept, but who knows what would happen if someone as devious as him got his hands on these sorts of systems. I think we're already seeing that. I'm into disinformation stuff, and the Russian disinformation flows in the last year. They're integrating computational disinformation into their propaganda strategy. It's super interesting. So he knows. Anyways, okay, next one. I'm a researcher. Anyways, okay, so next one. I think we should be very careful about artificial intelligence. If I were to guess what our biggest existential threat is, it's probably that. With artificial intelligence, we are summoning the demon. As AI gets probably much smarter than humans, the relative intelligence ratio is probably similar to that between a person and a cat, maybe bigger. So bingo. Ding, 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 ding. Yes, that's Elon Musk. If you guys couldn't tell, I didn't change this quote at all, if you guys couldn't tell by that. And then kind of last one, this person is very different than the others. But he said, once the machine thinking method has started, it would not take long to outstrip our feeble powers at some stage. Therefore, we should have to expect the machines to take control. I'll give you guys a hint. Academics in this field, very, very influential people from a historical perspective.
in the AI field in particular.
Yeah. I mean, yeah.
Yes, but also.
But no. Yeah. I mean, you guys in your field, like everything. Whatever. Okay. Oh, I'm clicking that wrong. Alan Turing. Yeah. So grandfather AI, and then also, cryptography, basically everything. Yeah.
Chomsky? What's Chomsky have to say about it?
I have no idea.
He said the LLM, like even
Oh, people about speech. I mean,
I mean, he's a linguist, so I don't know if I could engage with him on that, but I don't like Chomsky for many other reasons. So I don't consume any of his stuff. He has some very horrible opinions about issues, but not to let my politics seep in. Genocide denier. Anyways, factoring in risk. So I think one of the things I really want to highlight on the back end is that these systems and risk in general is like, and I said this before, is nonlinear. Once we start, hitting that upside risk or hitting that downside risk, that things diverge and can diverge really quickly. I'm not saying that risk is a bad thing. I think risk has, there's potential in risk. I think, the potential with AI is really great. Obviously, this is, maybe stretching it a bit. But, we really, I don't know. A lot of people think we could go a long way with these things. I think, there's other people and, also you guys in this room might have some thoughts, about this. But I don't know. I think it, we really have to consider a lot of different things in this equation. And yeah. Anyways, I'm kind of rambling at this point. I want to get your guys' opinions again. Do you guys think we're on the hinge or the precipice of history? This is a bit dramatic, but where do you think these developments and these kind of might take us? I'd be really interesting to hear any thoughts, anything really speculative too. Yeah. And we're like all like uploaded to this like consciousness. There's no like physical space anymore. Okay. Mm-hmm. So, oh,
That's the area where, if they saw and they're like the 2001 Space Odyssey debut work. Like,
And-
they sort of, meeting us and it's just,
it's not our problem anymore.
yeah.
I mean, I don't know about you guys, but I have a particular opinion on like evolution and intelligence that I don't know. I think, huh? Is-
I mean, see the one where this crazy Dutch man has video I believe studies mushrooms. Like the reason why apes evolved as humans, they ate mushrooms.
Oh yeah, the stoned ape theory. Oh yeah. I don't know. I've done mushrooms. That did not make me smarter, man. Anyways, I'm gonna say that I think that like if we look at history, like when creatures become qualitatively more intelligent than other creatures, that they stop acting with morals. Or if like we as humans, we think that there's specific creatures, and some of us have that this is relative. Like, for example, I don't know. I don't like killing dogs, but I'll happily kill any other animal because I think dogs are, to me, they are smart enough. Or I don't know. What if the AI decides, I don't know, some of these humans, they got it, but these other guys, they're just never going to catch up. Like, I don't know. I think, there's not a good track record for these things. And if a system like that developed, that I don't think they'd be very nice to us.
So do we want to avoid a very utilitarian value judgment in that case? Is that what you're trying to say?
Yeah, I would say so. I mean, yeah, if you want to kind of jump into the ethics of it a bit more too, I'd be happy to do that. But yeah, I would say, I don't know. I'm not a utilitarian, so that is definitely, that kind of seeps through with the things I'm saying here. But I don't know.
I feel like just a little more, either you can think about it either a little more reasonably or a little more short term, however you want to think about it. I feel like it's more a question of a social restructuring than anything. Because my take is that either government steps in and puts some limits on data usage, because the AI at its core needs data to do what it does. And right now, the laws and stuff coordinating that data don't exist because this kind of like abilities didn't exist before, so there was no need for them. And I think if the data like isn't cracked down upon, that we're just gonna see this exponential growth growing really quickly, and there's gonna be a social restructuring because of all the things that AI will be able to do that it used to take millions of people to do instead. So I think honestly, it goes one of two ways: that government really cracks things down on data usage and it slows down a lot, but it becomes a lot more safer, or a lot more safe, or it runs really quickly and we see this, social restructuring. I don't really know what it would look like, but probably, at that point it could go, utopian, dystopian, just depends on choices.
And what's it called? I just want to, because I know we are over time now here. I took a lot of this content from Dan Hedrick's Introduction to AI Safety course. These slides will be, they're all posted together. You guys can go through here. They're actually having this course. You get paid $500 to take it. It's an 8-week, I don't know, it's like 5 hours a week for 8 weeks over the summer, about kind of these concepts. A lot of the things I went over, directly from here. So if you guys don't have anything going on, that could be something interesting to look into. But anyways, yeah, I want to still have that. We're kind of opening a good conversation. Did anyone else have anything want to add in there?
I mean, we humans really have enough intelligence to make a decision about the we do dolphins are dolphins oh, you're less intelligent than me. They don't do that. So I think you're just using the sample size of one human race to think about what higher culture means. Because a lot of one particular between novels, especially Dark Forest, it's we project ourselves onto aliens, and aliens could never be way different from us. At least for research and ethics. So conquering others. So humans are known to conquer each other, conquer everything, but we don't know if aliens are going to get together.
Yeah.
Also, but then vice versa, we are programming from AI, so programs do us. That is kind of bad. But we're kind of doing.
I think, yeah, one of the strengths in these systems is that they look at things in a completely different way than us. So I actually think there's a lot of credence in that point. We don't have the intelligence looks very different. And it's likely that those other things would probably be pretty different as well.
I feel like if you don't want to shut down intelligence in its entirety, you have to take some assumptions, and the best we can do is look at the closest to empirical measurements